Hello, it's me again. Now, after watching video 1, I bet you understand how to produce carboxylic acid and the nature of carboxylic acid, which is a weak acid, right? So we will go to look at the core part, that is the reactions of carboxylic acid, okay? So there are a lot of reactions we have learned already. It's just a revision. So the first one, of course, we know is neutralization because it is an acid, right? According to what we learned in junior form, an acid react with an alkali, it will form only salt and water. That is indeed the definition of neutralization. So I will give you an example for each of the reactions. So for example, carboxylic acid, ethanoic acid react with NaOH. So I bet you know the salt will be from this cation and this anion, right? When we write organic salt, remember the anion is put at the first, okay? So that the negative charge and positive charge, they will be close with each other. Water, okay? So this is sodium ethanoate. Okay, this is the first reaction. And then we talk about the second reaction, that is with metals. If you remember, for a typical acid, when the acid is a typical one, it's not an oxidizing agent, it can only react with metals that's more reactive than copper, right? So let me give you an example. For example, this time, propanoic acid react with, for example, magnesium, then this anion and this one will form salt and hydrogen gas, not water anymore. This is not a neutralization. So remember, magnesium, when it turns to anion, a cation, sorry, it carries two positive. So it will be, after switching the charge, it will be 2Mg plus H2. Then you will have to balance it by adding a 2 in front of carboxylic acid. So this is magnesium propanoate, okay? So because it contains 3 carbon. Okay, this is the second reaction. We learned that before, okay? The third one, do you remember what it is? Is we add with carbonate ion or hydrogen carbonate ion, right? If you remember, they will form, of course, the salt. The salt is the common product together with carbon dioxide and water. Okay, now let me give you an example respectively. For example, we use ethanoic acid again with sodium carbonate. So what will be formed? You will have the salt, right? The salt CH3COONA together with carbon dioxide and water. The sodium has 2, right? So you put a 2 here to balance Na, and you put a 2 here. So yeah, it's balanced already. Okay. Oh, let us try another one with hydrogen carbonate, NaHCO3. So can you predict the product? And give you 2 seconds. 1, 2. Okay, I bet you know the answer. This is the sodium ethanoate together with carbon dioxide and water. Okay, so is it balanced? Yeah, it's balanced. Okay, so this is the third reaction. The fourth one is basically the reaction of alcohol. So you should know what it is. A reaction that involves alcohol and carboxylic acid, of course, is esterification. We already learned this in last chapter, esterification. Okay, so I told you when an alcohol react with a carboxylic acid, a water will be eliminated. You need concentrate sulfuric acid as the catalyst. Pull the water out and combine the rest of the parts to form the ester. So you will get this one and water. Okay, let us have an example. methanol react with ethanoic acid. So, right, the water will be pulled out, then you will get okay, can you tell me the name of this ester? Is methyl. This the first part is coming from alcohol. The second part is coming from carboxylic acid. Methyl ethanoate, right? 好啦 the fifth reaction, this is the only reaction that's new, that is reduction. Now, if I told you, if you remember, carboxylic acid can be formed from the oxidation of alcohol, right? For example, CH2OH, right? You oxidize it to carboxylic acid all the way, okay? If you use V+, and the oxidizing agent is, we learned this in the previous chapter, that is acidified dichromate ion, right? If you want to turn it back, this is reduction, right? The opposite of oxidation, this is oxidation. So you will use a reducing agent, and I need you to remember the reducing agent this time. That is IALH4 in dry ether. Okay, LiAlH4. You don't have to know the mechanism, okay? You don't have to know the mechanism because it's quite complicated, but you have to know the name, okay? Because sometimes the question may ask you to name it. So it's called tetrahydroaluminate, okay? Now we put it in dry ether because it will react explosively in water. So we cannot use water as the solvent. So basically what's doing is CH3, COOH, right? If you add lithium aluminium hydride in dry ether, it will turn to CH3, CH2OH. This group will go back to alcohol, right? Now, but if you have to write a balanced chemical equation, for oxidation, we add oxygen, right? But for reduction, we add hydrogen. I demonstrate an example to you. For example, if you have to reduce carboxylic acid to this ethanol, okay? Now then, you have 2H, 1H. 2O, 1O. Then we need water to balance the O. Once we balance the O, we use H, okay, bracket H to balance the hydrogen. So CH3, okay. So here you have 3 hydrogen, 1, 2. But here you only have 1, right? No, you only have 1. But here is 1, 2 plus this 2. Okay, so here you only have 1. If this part is the same number, right? This part is the same. So you need 4 bracket hydrogen. Okay, as the name goes, lithium aluminium hydride. Okay, I mean this tetrahydroaluminate is functioned by providing hydride ion. Okay, but the mechanism is not included in the syllabus. So we use bracket hydrogen to balance the number of hydrogen. Okay, so that's the end of all the reactions of carboxylic acid, and that's the end of this chapter. For part 3 of the video, I will go through the natural notes with you because I'm afraid it will over the length. Okay, so let me make a plenary. Okay, so there are altogether 5 reactions. The first one is neutralization. Second one is reacting with metals. It's exactly the same as what we learned in IGCSE. Salt and hydrogen gas will be produced. But remember, it only reacts with metal that's more reactive with copper. And it reacts with carbonate and hydrogen carbonate. And then salt, carbon dioxide, and water will be produced. Esterification is what we learned last chapter. Okay. And this one is nil. Reduction is the reverse of oxidation. It can help you to turn the carboxylic acid back all the way back to alcohol. Now this one, now for oxidation, you can get the aldehyde if you isolate it out in the middle by distillation, right? But for reduction, it will go all the way to alcohol. You can quench the reaction and take the aldehyde out. Do you understand? So if you have to prepare aldehyde, do not get it by reducing the carboxylic acid, but instead you have to oxidize the alcohol with distillation. Okay? I will go back to you in part 3 and fill in the blanks of the lecture notes.